Hi, good morning, class. How are you today? Okay, I have two news for you guys. One bad news and one good news. Which news first?
Good news.
Okay, the good news is we have only 11 lectures remaining for this whole semester. Okay, 11 lectures and 8 sections. Hopefully, we'll have some time to review for final. And bad news is, yeah, it's about the final. So there will be the final on May 3rd, 2014. I will give you more information about the final in detail in coming week. So please don't miss my lecture, okay? So here today I'm going to talk about how to create new function uh, by using the whole function that we learned in earlier class. Okay, so before that, motivation for you. Let's talk about our old friend, the real number. They are always with us. So we know that how to add and how to subtract, how to multiply, and as usual, I know how to divide. Okay? At this point, it seems like very obvious how to add 3 and 4, how to multiply 2 from 4, multiply and divide. Okay? So, but let's try to remember our very earlier days of learning process. Even we had to learn how to count the real number. That's like the 1 through 10. And at some point later, we learn how to define some. I remember my teacher used to tell me that like the 3 here, if you want to add, draw the 4 bar, and if it's here is the addition sign, means just count simultaneously 1, 2, 3, 4, 5, 6, 7, and this is 7. Okay, how to subtract this? Okay, at that point, he used to tell us like draw 4 bar, and I have to subtract 2, so cancel 2. What's the remaining is the subtract. It's a 2 only. Okay, same as the multiply and division was defined. Okay, and at this point, you may have some question like that. If it's like we can define addition, subtraction, multiplication, and division for the real number, can we do the same process for function? What do you think, guys? What do you think? Yes, we can do. We can add, subtract, multiply, and divide so that we can create a new function. I will just answer your first question. It's like real number. We can yes, we can add, multiply, subtract, and divide function, creating new functions. We say that we can define, then the obvious question in our mind is how we can add, multiply, and divide the function. Okay, so here is my topics for today is algebra of functions. We'll try to add, multiply, subtract, and divide function. Okay, so just to recall from the last lecture is that I defined a function as a machine. That's the function as, or just for easy as bar. It's a function, or it's a machine, or you can say the correspondence between input here, and input goes here, and whatever come out for h of x. Okay? So And I'm going to create the new function, so I need some function. Let's just define two functions. Let f and z be two functions, okay? Two defined functions. Then definition, very first definition. The sum, sum function, okay? The sum function f plus d. This is notation of my new function. It's perfectly makes sense because I am adding two functions here, the addition sign, so it's a notation, okay? How it's defined is f plus g is equal to how it's defined. Just a definition. It says that f of x plus g of x. It's the first definition. Okay? Then what kind of x are allowed here? What do you think? This x must be in the function of a domain of function of f, and same as domain of function of g. Means the x must be in the domain of f and domain of g simultaneously. Okay, so let's write. So domain of f plus g is equal to, in set notation, collection of all x belongs to R, so that x belongs to in the domain of f and domain of g same time. Okay, so here just for more clarification, let's say what I was saying, that here is the function of f, my function f, it's a function of or f of bar, and these x come from the domain of f and comes out f of x. Same as I have a function g, okay, g of var, that's x goes inside, comes, and this x must come from domain of g. So what the function f plus g will have a bigger function. So f plus g, and we know that at that point we know that what comes outside, it's f of x plus g of x. Okay, the question is that what kind of x? Okay, here x goes inside, and these x must be in the domain of f, and same time it must be in the domain of g as well. That means it must be in the intersection, this part. Okay, from here let's go to x. Make sense? Okay. Likewise, I just want to reduce some, or likewise, the difference function f minus g is defined as f minus g of x is equal to, by definition, f of x minus g of x. Okay, it's the same as this x must be in the domain of f and domain of g simultaneously. Similarly, here is the product function. Okay, the product function, it's just fg. How it's defined is product of fg of x is equal to, by definition, f of x times g of x. You have to be very clear here. So here f times g is just a simple multiplication, or in some book they write this way: f dot, solid dot, f of g of x is equal to f of x times g of x. It should be, you should not be confuse yourself, it's a solid dot, just a simple multiplication. Okay, and same as the domain will be in the domain of f and domain of g. Okay, so the problem is that here that the problem is the division. Remember, there is some problem with division of a real number. Okay, now division. The division of the quotient function f over g is defined. I want to give some more emphasis here. Defined as, how it's defined, you know the pretty much something here, what's going to be here. It's by definition, it should be the f of x over g of x. But the problem is that the x must be in the domain of f and domain of g, but the g in the denominator, so I cannot allow the x where g of x will be equal to 0. Okay, here, what say that, usually I have the domain of f, and here is the domain of g. Usually the x must be from here, intersection, but this time I need the one more say here g of x is equal to 0. Then I have to restrict, I have to get rid with such kind of x where g of x is equal to 0, because g of x is in the denominator. So this time I will have the x are allowed only from here. Okay, so here in the intersection of domain of f and domain of g, but it cannot be, the x cannot be such type where g of x will be equal to 0. Okay. Let's do the one, let's make clear by one example. Okay, it's example 1. So let f of x is equal to x plus 1 and g of x is equal to 2 over x. Since we are dealing with sum and multiplication, this all the three real number, so first I want to talk what kind of domain. We have to be careful with the domain, so I want to talk with the domain. Okay, so what is the I think you can use the simple idea here. What kind of, it's a radical equation, so what kind of x are allowed here? Well, yes, you're right. It's this inside the radical must be equal to greater or equal to 0. That means x must be greater or equal to -1. Okay, so domain of f will be equal to -1 to infinity. And same as here, g is the rational function, so domain of g will be equal to everything except x is equal to 0. So my -infinity to 0 and union, I have to exclude 0. So this, or I can, let's draw in the picture. So here is the -1, and so my domain for f will be everything right of the -1 included. So here it should be 0 here, and so goes -infinity, and that's my domain. Now let's define the sum. by definition, you know that what's going to be f of x plus g of x, and what's f of x is x plus 1 square root, and what's the g of x is 2 over x. And yeah, that's pretty much all, yeah. And quick, same is what will be the f minus x? By definition, f of x minus g of x. And I think not from. Let's do the one more here. F times g of x, and again by definition, f of x times g of x is equal to, that's and for all three cases, what's the domain of these is intersection of domain of f and domain of this. In all cases, I mean in these three cases, domain is equal to intersection of -1 to infinity, and where I can here it's everything, so the intersection will be -1 through 0. I have to exclude 0, union 0 to infinity. Okay, so it's like that. We will have some trouble when I am finding the quotient. So f of x over g of x, and here will be the x plus 1 divided by 2 over x. Okay, so for this guy, I have to restrict the more x's from the intersection of the f and g, so that 2 over x should not be equal to 0. But here 2 over x is never going to be 0, so this time we are lucky, no restrictions. Okay, we are lucky this line, lucky face. Okay, but it may not be the always same cases. You have to be careful when you are trying to find the domain of f intersection g. Any questions here? Okay.
Okay.
Thanks, Elizabeth.